So this is my video on Tech Demo 3. The questions we'll be following are on the left side of the screen. And for the first question we're going to do is graphs a solid region x squared plus 2z squared is less than or equal to y less than or equal to 18 minus x squared, but x has to be less than or equal to 0. So when we graph that, we'll go ahead and plug that first equation in directly. So x squared plus 2z squared is less than, which we'll find down here, y, which is less than 18 minus x squared. Then we want to give our bounds, which we know which is x is less than or equal to 0, which we'll use the curly lines and put that in. And we'll end up getting this shape. Alright, now we're going to take that off the graph by clicking on the red. Then we're going to do question 2, which is graph the solid region that lies outside the cylinder r is equal to 1 between spheres phi is equal to square root 2 and phi is equal to 2. So we're going to go ahead and we know that a sphere in cylindrical coordinates is x squared plus y squared plus z squared. Then we also want to give our bounds, which we know is between square root 2 and 2. So we know x squared plus y squared plus z squared is equal to that p squared. So that would be equal to, on the right side, is less than or equal to 4. So get that first sphere. And then we know on the left side, it cannot be, it has to be between square root 2. So square root 2 squared is just 2. And we'll get that sphere. Then now we need to cut out the cylinder r equals 1, which we use as squiggly line again for our bounds. And we know a cylinder is x squared plus y squared in a 3D region. And it can't be, it has to be equal to, the radius is equal to 1. So then we'll do greater than 1. Then we'll get that bead looking shape. Alright, and then for the last part, we're going to do graph the region in R2, which is mapped to the square with corners negative 1, 0, 0, 1, 1, 0, and 0, negative 1 by transformation. So first, I'm going to show how to first graph that first square, which z is equal to 0. We know it's a square on the xy plane. Then we have the squigglies for lines for our bounds, which is 1 is greater than x, and x is greater than negative 1. And then we have our y bounds, which is 1 is greater than equal to y, which is greater than equal to negative 1. But then we'll get that square. Now when we put it under, do our transformation, we'll again use z is equal to 0. But then our bounds will change, which is equal to 1/2 greater than equal to x, which is greater than or equal to negative 1/2, close. And then for a y, same thing, but for y. And there we go. So then as we compare them, we can see that it cut in half by our transformation. And that is all.